So today's topic is solving polynomial equations. This is 5.3. Our objective for today is to solve polynomial equations using all factoring techniques. We've gone over all the factoring techniques. We're just adding on a little bit of extra with the fact that these are going to be higher degree polynomials. So before we were working with quadratics and a couple cubes. Now we're adding on fourth degree polynomials and all that stuff, quartics and all that. Right? We'll demonstrate this on the exit ticket, the quiz, and then the unit test. It's the main places. Right up here, I added a little blurb for all of these where you can go to a video and watch how to do them, how to get the GCF out, how to factor, how to use your quadratic formula, use completing the square, or square trinomials, limits of two squares, and then factoring by grouping. Of all the different methods we're going to be using today. Next thing after that, we have our new rules. We're specifically going to focus on rule 1 for today. That's the main one that's needed for this class, but I decided since we're already going over rule 1, might as well go over all 3 rules. So we'll go over all 3. The little thing to have in our minds whenever we're doing this type of stuff. Once we're through all 3 of those, you'll set the you do. Again, this is review from last semester. It's just making it a little bit tougher. It's going from like a level 2 problem to a level 3 problem. All right. But you all know how to do these things. You all showed me last semester that you all can do this. It's a little bit of time and a little bit of practice. So we're going to do that. Once you complete all this work, you can go to the exit ticket. I will say this, a lot of you are skipping right to the exit ticket before doing these you do problems, and you're getting some not so nice scores on that exit ticket. I would make sure you're doing these you do problems before you start the exit ticket. Because a lot of the times I take problems from the exit ticket, put it on my you do, and change up the numbers. So it's slightly different, but it's still asking you the same type of problem. All right. So this is your chance to ask me any questions before the exit ticket.
Do you recommend writing it down or doing it digitally?
I would do a little bit of both. I actually like, when I'm actually taking notes as a student, I like to write things down. That's how I learn best. But, you know, we're in a digital age, so if you want to use digital stuff, you can do that too.
Okay, thank you.
Welcome. So let's start with simplifying radicals. We have 3 different things we're going to be focusing on. All right, so there's 3 different rules. The first rule is no perfect square factors are in the radicand. Now that's our fancy way of saying inside of the square root. So I can't have any perfect squares, like the ones we went over this morning, like 4, 9, 16, 24, 25, all those. Can't have those. So this 8 has a common factor of 4, which is a perfect square. So the square root of 4 is 2. So that's where that came from. All right. We'll go over a little bit more on how to actually do this step by step in a second. This is just more of the overview of the 3 different steps. So don't worry if this doesn't fully make sense yet. Our second rule is no fractions are in the radicand. Again, no fractions inside the square root. Like this square root of 5/16 is not okay because we have that square root on the inside. To get rid of it, we would break it up into 2 different square roots and simplify. And then we'd be done. We don't have a square root anymore. All right. And our last rule is no radicals appear in the denominator, which means that we have no square roots or anything inside that denominator. And square root of 5 isn't allowed. So what we do is multiply top and bottom by the square root of 5. Square root of 5 times square root of 5 gives you 5. You're just left with the square root of 5 on top. All right. Nice and simple. Those are our 3 rules. Kind of a little overview. Are there any questions on the wording for any of the rules? Not actually how to use them yet, since we haven't gone over that, but any of the wording. Like, does anybody need me to refresher on what radicand means or perfect square? or denominator, or radical? Anybody need any refresher on any of those words? So a radical is just our square root. We call it a radical because there's more than just a square root. So a radical is any type of one. So this would be a regular radical. I could also do a cube root, which is where I have a 3 right here instead. So that would also be a type of radical. We just can't have those type of things in this bottom. So that's a radical. Again, the radicand's the inside. Inside. That's clear all my drawings. Let's move down then to our first section. No perfect square factors are in the radicand. So that first rule. The steps I kind of follow are as a factor into perfect squares, break into different square roots. So I factored 180 into 4, 9, and 5. I'll show you how to do that in a second. Then I break it into different square roots. So square root of 4, square root of 9, and square root of 5. Then I simplify. Square root of 4 becomes 2, square root of 9 becomes 3. Square root of 5 can't be simplified, so it stays there. Right? Our last step is 2 times 3 equals 6. So my final answer will be 6 root 5. Are there any questions on that so far? The steps or anything? Before we go over how to get this right here. So any questions on the steps other than how to get this? And I won't know what you need to know unless you tell me. All right. So to find my different factors, I like to use a factor tree. So I can break down this 180 using my factor tree into, let's say, 18 times 10. And I can break down that 18 into 9 times 2. I can break down that 10 into 2 times 5. And finally, I can break down that 9 into 3 times 3. Right? So this is how I get a factor tree. I get everything down to its prime numbers. So 3 and 3 are prime, 2 and 2 are prime, 5 is a prime number as well. Are there any questions on how I did that factor tree? All right, now what we do is we circle the things that have pairs. So there's pairs of 3s, there's pairs of 2s, and we have this 5 left over. Right? We put the pairs together here. So 3 times 3 gave me that 9, 2 times 2 gave me that 4, and then we had that 5 left over. Right? Then we broke it up, square rooted what we could, simplified and all that stuff. That's how I found that 9 and the 4 and the 5. I used those two, had that left over. Are there any questions about this process before we go over another one? All right then. Simplify, yeah, so simplify just means that I square rooted that 4 to make it a 2. Let me draw like that. And square rooted that 9 to be a 3, and then multiply them. So it's whatever those last little bits of things that I need to do, like the square rooting, the nice numbers that we have on our piece of paper over on the side. or multiplying anything we might need to multiply. So let's see another problem. Let's go with, does anybody have a number they want me to try? Someone give me a number. Anybody at all? Anybody give me a number we can try this with? Some people give me some really nice numbers. Let's use that one right there. I don't think that one's going to be too nice. Let's go with 220. Okay. 220 is actually not going to be a very good number. No, it will be. It'll work a little bit. Perfect. All right, so I can factor these two into, let's say, 22 times 10. And I can factor these two into 11 times 2 and 2 times 5. So I have two 2's, I can circle those two together. So I have these two 2's together, and then I'm going to combine whatever's left over. So in my square root, I got the square root of 220. I'm going to break that down into the square root of 4 times whatever's left over, whatever did not have a match. So 11 and 5 didn't have a match, so I'm going to put 55. Right? Then I'm going to break it up into its different square roots. So it'll be square root of 4 times the square root of 55. Square root of 4 becomes 2. Square root of 55 doesn't simplify, so it stays the same. 5 and a 5. So that would be my final answer, 2 root 55. Because the 55 we saw couldn't be flipped over anymore, didn't have any more factors that are in common, so it can't be changed. Are there any questions about that process? Do you have any questions about anything I did along the way? How I got my factor tree or anything? How I broke it up? How I got 55? Perfect. So I got the 4 from the 2 and 2. Because 2 times 2 equals 4. I put those two together because they're matching. And I know that that's going to make that perfect square I want inside of there. The 55 comes from the two that are left over, the 11 and the 5. Because those don't have any matches, I know that those are going to stay inside the square root. So there's nothing we can do with them. There's no way we can take them out. So we're going to leave them inside here, 55. Right? The 4, on the other hand, can be square rooted. I can take the square root of 4 and get 2. So I end up with 2 square root 55. So the 4 came from the 2 and 2. The 55 came from the leftovers, the 11 and 5. Does that answer your question, or are you still a little confused? Welcome. Does anybody want to see another one, or should we move on? All right, we'll move on for now then. If you come up with another idea for a question, just holler. We'll move back to it. So now we got our next rule. Our next rule is no fractions are in the radicand. Again, inside the square root. So right now we have this example problem right here. We have a number inside the square root, which is that 1136. We can't have that. So what we do is we break it into two different square roots. One on top of the numerator, one on top of the bar called my numerator, one on the denominator. Then we're going to simplify next. Right? 11 stayed the same because I can't simplify that anymore. I can try, but the only two factors of 11 are 1 and 11. So there's nothing I can do. That one's kind of done. On the other hand, we know that the square root of 36 is 6 from our little chart on the right side. So our final answer will be square root of 11 over 6. Now there's one step that we have to make sure every time is that there is no denominator, there's no radical in the denominator, all right? So there's no square root in that denominator. Since there's none in here, we're good. If there was, then we'd go down to these steps down here. Are there any questions about this process? Breaking it down and then square rooting. All right, then. We'll move on for now. Come up with any questions, we can come back to it. We'll do a problem that combines both of these questions in a second. So we'll come back up to here in a second with this one. And again, yes, that's exactly right. It's not necessary because the denominator doesn't have a square root, right? That 6 doesn't have a square root, and so I don't need to do anything else. On the other hand, this problem down here has that square root of 7 inside the square root. All right, so that square root of 7 can't be on bottom. It's our rule. And so what we're going to do is multiply top and bottom by the square root of 7. We're going to multiply top and bottom by the radical in the denominator. All right, root 7 times root 7. The reason that works is because root 7 times root 7 can be rewritten as root 7 times root 7 in a single square root, which then gives us root 49, which is 7. All right. So what I can do, remember, whenever I have two square roots, is I can combine them into one. And then those will always become a perfect square since it's multiplying two numbers together. And so you'll always end up with that 7. The bottom radical always goes away, as long as you're doing this math right. All right. I have that 7 on bottom. I have to do a little bit of simplifying any extras, like this 2 times 7 I have to simplify. Maybe I have to simplify that 5. 2 times 7 equals 14. The 5 and the 14 don't have everything in common. So this is my final answer. Are there any questions about that process? Like why square root of 7? How did you get 7 on the bottom? Where did the 14 come from? Why didn't you combine the 5 and the square root of 7? Any of those type of questions? All right, then let's move on. Let's try another one of these. Try another one, clear all drawings, make up one on the spot. Let's go with something like square root of 16 over the square root of, let's go with 11. All right, so I have a problem like this right here. Actually, let's make this a little bit tougher. Make this square root of, that's not gonna work. Make it 18. All right. That's not. That's gonna be a nice number. Undo. We'll stay with my original one, 11. What I'm gonna do first, just like this says, break it into two different square roots. So I can't have the fraction inside. So I break it into square root of 16 over the square root of 11. Then I go simplify. All right, so that was step A right here. Now we're going to do step B right here. We can simplify the square root of 16 to be 4. And I have that square root of 11 on bottom. Okay. So this is where I have to check if there's a radical in the denominator. There is a radical. And so I come down to here. All right. So I got this right here. I bring this problem down here. 4 square root 11. And I follow this. Multiply top and bottom by the radical in the denominator. So I multiply top and bottom by that square root of 11. Square root of 11, square root of 11. When they're a 4 and a square root can't be combined, so I just got to go 4 root 11. Let's put them together this way. Over square root of 11 times square root of 11 gives me the square root of 121. So then I end up with 4 root 11 over 11. So square root of 121 is 11. That's my final answer. Are there any questions on that process? All right then, let's move on. Now what you got to do, now we've gone through all of the little bit of new stuff that we're going to be going over about that stuff. We're going to be going down to here to the you do review. All right, we got 3 different things that I want you to try and do, the 3 different examples. This first example, I put a little hint on there, make it equal to 0 first. Then I gave you how many solutions it should have. It should have 4 solutions, 1 with multiplicity 2 and 2 with multiplicity 1. Again, mult stands for multiplicity. I learned about that last time. This one has 4 different solutions, all with multiplicity 1. This one has 3 different solutions, all with multiplicity 1. All right. So again, move that 6x cubed over and then try and factor. I'm going to say factor using your GCF will probably be your best way, and then try and do it up above. Again, you have a bunch of different methods up here that if you forget how to use one method, you can go watch that video real quick. You have the rest of class to complete this, so 45 minutes, pretty solid amount of time. If you have any questions, as usual, you can ask me and I will help you. I will slowly put the answers on the board, all that good stuff. Start working. If you have any questions, let me know. We're free to work.